Welcome to my channel Simple Concepts by DJ. Today we are going to see a numerical solution circuit problem in nodal analysis. So this is the circuit diagram that is considered for observation, and in this circuit diagram they are asking us to find the branch currents. Branch currents are individual currents that are moving, that are looping around the circuit. Okay, so branch currents in this circuit will be I1, I2, I3, I4 and I5. You have five different branch currents that is looping in this circuit. So you need to find the value of the branch currents through the nodal analysis method. Okay, for nodal analysis method, we need to use the current law. Kirchhoff's current law we need to use. So in this circuit diagram, we need to consider two nodes. So this is A is a node, B is a node, and similarly C is called the reference or the datum point, which is connected to the ground. In this circuit diagram, you have three voltage sources, that is of value 6 volt, 5 volt and 10 volt are being placed. You have a resistor, so this is a resistive network. Okay, so now we need to find the value of the currents that is looping around the circuit. So let's get into the video. We need to find out individual branch currents. Okay, and we need to get the values in amperes. So let's get started. So the first step that we need to consider while using this circuit is on circuit is, let's consider node A. Okay, so node A position, I'm writing here node A. So node A I'm going to consider. In node A, I'm going to apply the Kcl formula. So Kcl means incoming currents are considered to be positive and outgoing currents are considered to be negative. So in point A, I1 is an incoming current, I2 and I4 are outgoing currents. So I1 minus I2 minus I4 equal to 0. I'm going to mark it as equation number 1. So now I'm going to find what is the value of I1. So for getting the value of I1 equal to, this is 6 volt, this is VA is the node voltage. So difference in the voltage is 6 minus VA, 6 minus VA divided by the resistor value, that is 6. So which is equal to 1 minus VA divided by 6. 1 minus VA divided by 6. This is the value of I1. So now next we need to find the value of I2. So the value of I2 will be I2. For finding the value, this current I2 flows from node A to node B. So the difference in the potential will be VA minus VB, and since the current is passing through the battery source, that is from negative to positive. From negative to positive, we need to take the value as positive value. So that will be I2 will be VA minus VB, VA minus VB plus this 5 volt plus 5 divided by the resistor that is placed in this branch. That is, the value of the resistor is 2 ohms divided by 2. So this is the value of I2. Now I'm going to find the value of I4. I4 is VA divided by 3. Therefore, I4, the current I4 value is VA, that is the node voltage at A, divided by the resistor, that is 3 ohms. So I had found the three values, individual values of the current I1, I2 and I4. I1, I2 and I4. So substituting it in equation 1, I'll be getting 1 minus VA divided by 6, 1 minus VA divided by 6 minus I2 will be VA minus VB plus 5 divided by 2 minus I4 will be minus VA divided by 3 equal to 0. So now simplifying this, I'll be getting 1 minus VA divided by 6 minus VA divided by 2 minus into minus plus VB divided by 2 minus into plus equal to minus 5 divided by 2 minus VA by 2 minus into minus plus VB by 2 minus into plus equal to minus 5 by 2 minus VA divided by 3 equal to 0. Okay, so now what I'm going to do is I have three different VAs, minus VA, minus VA, minus VA. So I'm taking minus VA outside the bracket and I'm putting 1 divided by 6 plus 1 divided by 2 plus 1 divided by 3. I'm getting 1 by 6 plus 1 by 2 plus 1 by 3 plus VB divided by 2, VB divided by 2 plus what is 1 minus 5 by 2? 1 minus 5 divided by 2 will be 2, so 2 minus 5, which is equal to minus 3 divided by 2. So the value is minus 3 divided by 2. So it will be 1 minus 5 by 2 is minus 3 divided by 2 equal to 0. So now what I'm going to do is I'm going to simplify this one. So minus VA into 1 by 6 plus 1 by 2. So 1 divided by 6 plus 1 divided by 2. 2 6 are 12, 12, 12. 6 6 2s are 12, 2 1s are 2 plus 2 6 are 12, 6 1s are 6. 7 8 divided by 12. So 2 4s are 8, 2 6 are 12, 2 2s are 4, 2 3s are 6. So 2 by 3, 2 divided by 3 plus 1 divided by 3 will be 3. 2 plus 1, which is equal to 3 divided by 3. So that is equal to 1. So 1 is the value here plus VB into what is 1 by 2? 1 by 2 will be 0.5, 0.5 minus 3 by 2. 3 by 2 can be written as 3 divided by 2 is 1.5 is minus 1.5 equal to 0. So this one will be minus VA plus 0.5 VB equal to 1.5. So this is equation number 1. So this is equation number 1. So what I'm going to do is I'm going to change the signs. So it will be VA minus 0.5 VB equal to minus 1.5. This is equation 1. We'll delete these things. So upon simplification, I'll be getting VA, I'm writing this, minus 0.5 VB, VA minus 0.5 VB equal to minus 1.5 5. Equation number 1. பாரு கேமரா ஓடிட்டு இருக்காங்க ஓடி செக் பண்ணிக்கோ VA minus 0.5 VB equal to minus 1.5. So this is the equation 1 I had formed by considering the node A. So now what I'm going to do is I'm going to consider node B. So node B. Okay. For considering node B, here again I need to follow the Kirchhoff's current law. So the incoming current is I have I2, I3 as incoming current and I5 as outgoing current. So I2 plus I3. So I'll be getting I2 plus I3, I2 plus I3 minus I5 equal to 0. So, okay, this I need to put it as equation number 2 because we have equation 1 over here. So, this is 2 and this is considered to be equation number 3. So, I2 value we have already found, so no need to calculate it. We need to find I3. I3 equal to, current I3 will be equal to, I3 equal to the difference in potential, that is 10 minus VB. So, 10 minus VB divided by the corresponding resistance that is being connected in this branch. That is the value of the resistor is 4 ohms divided by 4. So which is equal to 10 divided by 4 minus VB by 4 by VB by 4. So that will be equal to 2 2s are 4, 2 5s are 10. That is nothing but 5 divided by 2 minus VB divided by 4. 5 by 2 minus VB by 4. That will be the value which is equal to 5 divided by 2 minus VB by 4. So we have got this value, I3 value. So what is 5 divided, okay, we'll keep it as it is, 5 divided by 2. Right. So we have got the value of I2, I4, I1 and I3. So what is the value of I5 here? So I5 equal to VB divided by 4. VB divided by 4. This is the value of I5. So VB divided by 4 is the value of I5. So you have got all the values. So what I'm going to do is I'm going to substitute these values in this equation. So if I substitute the values here, I'll be getting I2 plus I3 minus I5 equal to 0. Right, I'm substituting it in equation number 3. So I2 value is VA minus VB. See, I2 plus I3 minus I5 equal to 0. So I2 value is VA minus VB divided plus 5 divided by 2 plus I3. I3 value is 5 by 2, 5 divided by 2 minus VB by 4, minus VB by 4 minus I5 minus VB by 4 minus VB divided by 4 equal to 0. So I'm going to split the terms. It will be VA by 2 minus VB by 2 plus 5 by 2 plus 5 divided by 2 minus VB by 4 minus VB by 4 equal to 0. So now what I'm going to do is I'm going to take all the terms, A terms on one side, B terms on one side. All the identical terms I'm going to club it. So I have only one VA. So VA divided by 2. Next I have 3 VBs. So minus VB will be taken outside, and inside the bracket I will put half plus 1 by 4 plus 1 divided by 4. Okay, so 3 VBs plus 5 by 2 plus 5 by 2. What is 5 by 2 plus 5 by 2? 5 by 2 plus 5 by 2 with 2, 5 plus 5. So it will be 10 by 2. 2 ones are 2, 2 fives are 10. So it will be plus 5. Plus 5. Plus 5, when it is taken to the right hand side, it will become minus 5, which is equal to minus 5. Equal to minus 5. So now what I'm going to do is, I'm going to simplify this term. So VA divided by 2 will be 0.5 into VA. 0.5 into VA. So now here, what is 1 by 4 plus 1? 1 by 4 plus 1 by 4 will be 4. 4 for 1 plus 1, which is equal to 2 by 4. 2 ones are 2, 2 twos are 4, equal to half. You get half. Half plus half is 1 minus VB. VB equal to minus 5. Okay, so zero point 0.5 VA minus VB equal to minus 5 will be equation, if this is considered to be equation number 3, this will be equation number 4. Assume it to be equation number 4. So you now what you're going to do is you need to find the value of VA and VB. So VA and VB, here you have equation 2, here you have equation 4. So by solving the simultaneous equation 2 and 3, considering 2 and 3 and solving the equation, you will be getting values for VA as well as for values VB. Okay, so considering 2 and equation number 4. So I'm considering equation 2. 2 and 4. If I consider 2 and 4, see, second equation, I can multiply the second equation by 0.5. Okay, so when I multiply second equation by 0.5, it will become second equation multiplied by 0.5, 0.5. So it will be 0.5 VA, 0.5 VA, 0.5 VA minus 0.5 into 0.5, 0.5 into 0.5, which is 0.25, 0.25 VB, 0.25 VB, VB, 0.25 VB equal to minus of 1.5 into 0.5, 1.5 into 0.5, 1.5 into 0.5 will be 0.75, 0.75, 0.75. So when I multiply by 0.5, 0.5 VA minus 0.25 VB equal to minus 1.5 into 0.5 will be 0.75. So now I'm considering, I'm putting the fourth equation here. 0.5 VA minus VB equal to minus 5. This is equation number 4. So when I simplify, I'll be 0.5 VA and 0.5 VA will get cancelled. So I'm going to change the signs over here. So when I change the signs, I'll be getting 1 minus 0.25. 1 minus 0.25. 1 minus 0.25 will be 0.75. 0.75 VB equal to 5 minus 0.75. 5 minus 0.75 will be 4.25. 4.25. Therefore, VB equal to 4.25 divided by 0.75, which is equal to 4.25 divided by divided by 0.75, which is 5.66, which is equal to 5.66 volts. The value of VB will be 5.66 volts. So now with the value I'm going to substitute it in equation number 2. So equation 2 is VA minus 0.5 VB minus 0.5 VB VA minus 0.5 VB equal to minus 1.5. VA minus 0.5 VB equal to minus 1.5. So VA minus 0.5 into 0.5 into VB. VB is 5.66. 5.66 equal to minus 1.5. So VA minus 0.5 into 5.66. 0.5 into 5.66 will be 2.83. 2.83 equal to minus 1.5. Therefore, VA, which implies VA equal to minus 1.5 plus 2.83 plus 2.83, that is nothing but 2.83 minus 1.5. You get 1.33 volts. You get 1.33 volts as VA. As VA. So VA is 1.33 volts. VB is 5.66 volts. So you have got the value of VA as well as the value of VB. So they are asking us to find the branch currents. So we know the branch current I1. I1 can be expressed as 1 minus VA by 6. So I1 equal to 1 minus VA. What is VA? VA is 1.33. 1.33 divided by 6. Divided by 6. 1 minus 1.33 divided by 6. So that will be equal to 1 minus 1.33 divided by 6. 1.33 divided by 6 is 0.22. 0.22, which is equal to 1 minus 0.22. 1 minus 0.22 will be 0.78. So that is 0.78 amperes, which is nothing but I1. The value of I1 is 0.78 amperes. So now what is I2? I2 will be VA minus VB. VA minus VB is VA minus VB. So VA is 1.33 minus 5.66 minus 5.66 minus 5.66. VA minus VB plus 5 equal to divided by 2. So it is 0.33 amperes. 0.33 ampere. Okay. So now value of I3. So I3 value is 5 by 2 minus VB by 4. I3 value equal to, what is 5 divided by 2? 5 divided by 2 is 5 divided by 2 be 2.5. 2.5 minus BB by 4 minus 5.66 divided by 4 minus 5.66 divided by 4. 5.66 divided by 4. 1.41. 1.41, which is equal to 2.5 minus 1.4. 1.41 equal to 1.09. 1.09 ampere. So what is I4? I4 is The value of I4 current is VA divided by 3. I4 is VA divided by 3. So I4 equal to VA by 3 is 1.33 divided by 3. 1.33 divided by 3. 0.44, which is equal to 0.44 ampere. What is I5? I5. I5 is nothing but VB divided by 4. So VB divided by 4 is 5.66 divided by 4. 5.66 divided by 4, which is equal to 1.41, which is equal to 1.41 ampere. So we have got the value of I1, the value of I2, the value of I3, the value of I4, as well as the value of I5. So these I1, I2, I3, I4 and I5 are called as branch currents, and they are asking the value of these branch currents separately. So by solving this formula, by solving this equation, finally we have arrived at the values of these branch currents. Okay, so these are the answers: I1 value, I2 value, I3, I4, I5. These are the individual currents, values of individual currents which are looping in this circuit. Okay, so here we come to the end of this problem. Thank you all for watching this video. Please subscribe for more interesting and upcoming videos in this lecture session. Thank you all.